Hi there, welcome to this lesson on how your brain can change itself. So that statement in itself is kind of amazing. Your brain can change itself. How many machines or devices or computers or phones that exist that you know of can change themselves? Well, the answer is none. There are no computers or machines out there that can do that, but your brain can. And the way it does that is it changes its structure and function in response to the experiences you have across your whole lifetime. So your emotions, your memories, your actions, all of your behaviors at any moment can change the trillions of connections between the billions of neurons that exist inside your head. And because of this change across your whole lifetime, that makes your brain, the structure and function of it, completely unique. So, and therefore makes you unique. There is no brain that has come before or will exist in the future that is the same as your brain, because no brain and no other person has had the same experiences that you have that have ultimately shaped the structure and function of your brain. So that's what this lesson is about, and there's three different aspects to the way in which your brain can be shaped by your experiences that I want you to take away from this particular lesson. So the first one is the way this whole process works. So this process that we call brain plasticity, the way in which the structure and function of your brain changes across your whole lifetime, right the way at the beginning of life, from birth all the way through to the end of life, and the way that's different across those different time scales. The second thing is how it works, how this brain plasticity works, how it shapes the structure and function of your brain and changes those connections between different neurons. Now finally, and perhaps the most exciting aspect of this particular lesson, is these new techniques, speculative techniques that are being developed by neuroscientists to try and promote this plasticity when we reach adulthood. So that's trying to put your adult brain back into a kind of juvenile-like state, into a childlike state, to put it into a state where you can learn like you did when you were a child, but inside an adult's body. So that's the final aspect of the lesson. So let's get on with the lesson. So the really major changes to your brain, this brain plasticity, happen during your childhood. So soon after you're born, all the way through to about 9 to 10 years of age. That's what we mean when we say childhood. And this is when the brain really is most prepared to learn new information and learn new skills. So you're honing your senses, your vision, your hearing and so on. You're learning to walk, you're learning to run, you're learning to communicate both verbally with language and non-verbally with your body. And you're learning a new language as well. And at this point, you have the capacity to learn any language that you want to. And it's also when your attachments are formed with your caregivers, your siblings and your peers, and also when your emotional well-being and intelligence is put in place. So at birth, we're born with as many synapses, with as many connections between neurons in our brain that we need for the rest of our life. That's for the rest of our life. So that's an incredible fact. We don't actually need any more neurons or need to grow any more neurons from when we're born. As soon as we're born, we have as many neurons as we need for the rest of our life. So at birth, your cortex, your cerebral cortex, which is that bit that sits across the rest of your brain, the superficial part of your brain, has about 2,500 synapses, so 2,500 connections between all of the neurons in your brain. But by age 3, that number has grown to 15,000 connections. So now 15,000 synapses between neurons. So you've already grown many more connections than you had from when you were born. And the reason is the brain over-delivers at this point. What it does is it sort of sends out a kind of net of all these connections that you might need in your brain to essentially learn anything. It doesn't know what environment you're gonna land in. It doesn't know what household you're gonna arrive in at birth. It just knows that it needs to set up this learning machine. So it doesn't know, for example, whether you were going to be born into a Spanish household or a Japanese household or a Chinese household. So it sets up all your connections to learn any language that you might need to in that particular household. And that applies to everything. So essentially you have more connections in your brain than you're going to need. And what happens is you hone in on the connections by learning and using them. So we have this incredible heightened capacity for learning, and this is most prominent during our childhood. So there are what we call these windows of opportunity to get really good at learning those critical behaviours that are important for later in life. And we have different windows of opportunity for different neural circuits in our brain that controls different behaviours in the environment. And the timing of those windows of opportunity are actually optimized for when it's best to learn that behavior, whether it be language or learning to see or learning to hear. But as a rule of thumb, the brain develops back to front. So it starts right at the back here in the visual parts of the brain and gradually moves its development forward, all the way forward to the frontal part of your brain in this area called the prefrontal cortex. So therefore the behaviors that you develop reflect, and the order in which that happens reflects the order in which your brain actually develops. So the first things to develop are your sensory functions like vision, hearing, touch, smell, and so on. And then what comes next is your ability to kind of move and you're around in your environment, walking, running, and so on. And also your language skills, both verbal and non-verbal language skills. And then finally you move on to what we would call higher order cognitive functions, or higher order conscious rational thought, which is controlled by the front part of your brain here in the prefrontal cortex. And there are time windows, these critical time windows for us to learn these behaviors. If we don't learn them within those time windows, then some behaviors may actually be impaired or completely lost later in life. So how does this neuroplasticity work? How do we form new connections in our brain? Well, the more we learn new skills and behaviors, emotions, and so on, and repeat them, the stronger and secure these ingrained synapses become. These connections become more and more ingrained in your brain. So it's really like the more you use your neurons and connections, the more frequently you use them, the stronger they become. And neurons and connections that are rarely or never used during development actually end up dying off later on. And this follows what we call a use it or lose it principle. So the more you use connections, the more they survive, and the less you use them, the less they do. And this isn't a passive process for the brain. So during your childhood and through to adolescence, the brain actively prunes back, it actually cuts back the connections, the pathways in your brain that you're not using for particular behaviors. So this is what I meant, early on, that the brain sets out all of these connections just to give us the potential of anything we need to learn. Then we start using some of them to learn particular things, like a particular language, and then the pathways and connections we're not using, they get actively cut back or pruned back by the brain. And this is why an adult has about half the number of synapses or connections than a 3-year-old. So we're just left with the brain pathways that we've actually used. So to give you a tangible example, if you compared the brain, or these studies have been done as well, if you compare the brain of someone who's learned to read with someone who can't read later in life or even in childhood, the structure and the function of their brain looks completely different. So the person who's learned to read has the connections and the neurons and the pathways that allows them to interpret the visual aspects of a word and what that word actually means, where the person's brain who hasn't learned to read just doesn't actually have those neurons, doesn't have those connections, doesn't have those brain pathways that allow you to do that aspect of reading. So during adolescence, there's significant brain growth in the teenage brain. And this synaptic pruning that we just talked about actually begins here at the back of the brain and works its way forward to the front of the brain. This is really important because it means that in a teenage brain, this frontal area, which we know is really important for conscious rational thought and regulating our emotions, isn't fully developed. And perhaps most importantly, not just that it's not fully developed, it's not fully connected up with the rest of the brain. And why that's important is because this part of the brain is the frontal part of the brain is typically heavily connected up with the emotional parts of the brain. And one of its roles is to regulate the emotional parts of the brain. So what you find in teenagers is, because these connections aren't there, they rely much more heavily on the emotional parts of the brain than we do as adults. And the emotional parts of the brain, structures like the amygdala, which sits in the limbic system, are heavily involved in how we process emotion, how we perceive emotion, our emotional memories, and so on. And they're really a kind of a much older part of the brain in which we would have used in much more sort of fight, flight, survival situations. So when you start to sort of think about the teenage brain in that way, it makes you realize they don't have the brain connections yet, or the brain capacity to actually regulate their emotions. And this really explains quite a lot of why they're often so emotional, can be so irrational, can sometimes be aggressive, can sometimes be very risk-taking in their behavior and impulsive. And you can't really pin it down to them. It's actually because as of yet their brain isn't fully developed, and particularly not fully developed for managing and regulating their emotions. So this is actually a very important issue obviously for parents, teachers and teenagers themselves, and also incredibly complex. So consequently, we've actually put together a whole course to help you understand the teenage brain. Up until relatively recently, we actually thought that as you moved out of the teenage years and into adulthood and then into old age, that the brain was fixed. It didn't change itself, that the connections between those different neurons that we've talked about are fixed and are not malleable. But actually, research has shown over the last 10 to 15 years that the brain never stops changing. It's constantly changing and it's constantly learning. So as we age, there's no doubt that this neuroplasticity, the ability of the brain to change its structure and function, does decline with age, but it doesn't stop, it doesn't halt completely. New neurons can appear, and in different parts of the brain, right up until the day that we actually die. So this plasticity is there from cradle all the way through to grave. And you might wonder about different ways in which you can promote that plasticity, and there are actually many quite easy ways to do that, and particularly so well-being activities like exercise and meditation and getting good sleep, healthy eating really help with promoting plasticity. And they also help with this plasticity itself, can help incredibly with actually repairing the brain after it's been diseased or damaged by a stroke or trauma or Alzheimer's and so on. So we cover both of those two things, how you can exercise your brain and how you can repair your brain, in the next two lessons in details. But if you're really interested in understanding and learning about those strategies, you could take our other signature course, which is called Brain Health and Mental Wellbeing, in which we cover in detail exactly how you can promote brain health and plasticity to help your well-being. One of the most exciting developments in neuroscience in the last few years has been the development of techniques that actually promote plasticity in an adult brain. So this is trying to put the adult brain into perhaps a juvenile-like or childlike state to encourage the same kind of structural and functional changes to the brain that we see in a child, but in an adult brain. So imagine having the learning capacity of a child, but in an adult. So the things like learning to speak multiple languages, for example, that you can do as a child, or rapidly learning a language, learning how to play the piano, learning all those motor skills like running and walking and so on that you have. But imagine doing that as a 70 or 80-year-old. So where we're using these techniques to promote plasticity. This is one of the kind of most exciting developments in neuroscience, where we're not a million miles away from these techniques being available, but lots of them are kind of speculative at the moment and being used in animal models. But I just wanted to share a few of them with you. So the way nearly all the techniques work is that they try to remove the brakes that are put on plasticity as we move into adulthood. So the brain actively puts on brakes to slow down plasticity as we get older and older and older. And it does that both in a kind of functional sense and a structural sense, and all these techniques try and remove those brakes. So for example, things like sitting in the dark for long periods of time has been shown in animals to remove some of the structural breaks on neurons trying to form new connections, for example. And other techniques like pharmacological manipulations, drugs, and brain stimulation have encouraged sort of functional changes, the balance between how excited or how suppressed or inhibited the brain becomes to promote plasticity in adulthood. But perhaps the most promising techniques are a combination of some of the techniques you might be familiar with, like learning and brain training techniques to help you encourage and improve your abilities, and maybe memory abilities or whatever they may be, with some pharmacological manipulation or brain stimulation manipulation. They seem to be the most promising for promoting this kind of plasticity, this childlike plasticity in adulthood. But one note of caution with these techniques is there's a bit of an ethical dilemma, because perhaps you don't want too much plasticity. Perhaps there's a reason why the brain has put these breaks in place so that our brain doesn't become out of control with too much learning as we get older. And the brain is always trying to kind of find this balance between stability, the habits that we have formed, which we perform over and over and over again, and plasticity, the ability to kind of learn new things. And we might not want to disrupt that balance too much with these new techniques. Okay, so the key takeaways from today's lesson are that plasticity is there and present across our entire lifetime, but we have what we might call waves of plasticity that are much more prominent and stronger and promote learning during childhood and through adolescence, but start declining as we move into adulthood. And the second thing that we've talked about is the way in which plasticity works, and that's the way in which the trillions of connections that we have between neurons, between the billions of neurons in our brain, can be changed at any moment by the extent to which we actually use those connections. So this use it or lose it principle, in which the more you use a connection between neurons that controls a particular behavior, the more that connection gets strengthened and the more it stays in place. And the less you use other connections, the less strong they become, the weaker they become, and eventually they may die off from not being used at all. And then finally, the third thing that we've talked about, and the third key takeaway, is these different techniques that are now being developed for promoting plasticity into adulthood and trying to put the brain into this childlike state, to squeeze out some of that kind of learning, to promote some of that learning that we have as a child, but in an adult brain. So I hope you enjoyed the lesson, and see you in the next one.